Okay, this is 4.2 of geometry. So we've talked about congruent triangles and how we need to have all the sides congruent and all the angles congruent, and then the triangles are congruent. That's still true, but it turns out that there are a few ways that if we know a few key pieces, we know that the triangles are congruent. So one of those things is called the side postulate. If I know that all three sides are congruent, then it turns out that the angles are congruent and the triangles then are congruent. So before, where I needed to get all three sides congruent and all three angles congruent, now I don't need to get all of that. If I use the side postulate, I just need to get that the three sides are congruent, and then I have enough information to say that they are congruent triangles. So, if we look here, they have taken triangles off of this roller coaster, and they've written a proof. So up here, we are given that LM is congruent to NP, and we're given that LP is congruent to NM. So if we look at their proof down here, here's the given, and then I'm allowed to say that LN is congruent to LN by the reflexive property. So then I have that the three sides are congruent, so then I can say that the triangles are congruent by side. So, we've got the similar proof down here. Try to fit in a two-column proof. So BC is congruent to BF, and CD is congruent to FD. That was given. And then if I look at my picture, my last side is BD, so I could say that BD is congruent to BD by reflexive. Then I have all three sides congruent, so I can say that triangle BCD is congruent to triangle BFD. And that's by SSS. Okay, another one that we can use is called the side angle side postulate. So if I know that a side angle and a side are congruent, then everything else is congruent, and I'm allowed to say that the triangles are congruent. They need to come in order, though. Do you see how this goes? Side, angle, side. The angle needs to be between the two congruent sides. Okay. What other information do you need to prove that triangle DEF is congruent to triangle FGD by SAS? Okay, so let's look here at our picture. I have one pair of sides marked. And I also have reflexive, so I could also say that DF is congruent to DF. So I have two sides. Now if I'm going to use side angle side, I need to also have that their angles in between the sides are congruent. So I need this angle and I need this angle. If we split this up and look at these triangles, looking at these sides and this angle, there's my side, and this angle. I've got side, angle, side. So I would need to know that EFD is congruent to GDF. So let's look here at this picture. I've already got it marked that the angles are congruent. Again, I can use reflexive to say that that side is congruent. And I'd need the side, angle, side to be in a row. So I have right here side, angle, so I'd need this side down here. So I need to be able to say that this side is congruent to this side because I'd have side, angle, side over here. So I would need that LE is congruent to NB. Okay, identifying congruent triangles. So we're going to look at these pictures. Oops. Line there. We're going to look at these pictures and see if I can say that the triangles are congruent. So if I look at A here, I have, let me switch colors. I have side, angle, side. So I can say these triangles are congruent by SAS. Oh, because it also matches up to side, angle, side over here as well. If I look at B, I have side, angle, side. But if I go over here, I have side, angle, and then my side's over here. It's not right there where I need it to be. So I can't say that these are congruent. So not enough info. Okay, if I look down here, I've got side, 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 and side, side, side. So by SSS, these are congruent. And if I look here, I've got side, 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 and side, side, side. So I can say this by SSS. Or I could use SAS. It's not quite as obvious, but these are vertical angles. So if I took those as vertical angles, then I'd have side, angle, side, and side, angle, side. So either one would work. You just need a little bit more work for SAS. Okay, let's look down here. I've got side, 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 side. So I could use SSS. Or can I use SAS? Well, let's see. If I take side, angle, side. So I use the 2 and the 3. If I look over here, the 2 and the 3 don't have the angle between them. The angle's over here. So I'm looking at angle, side, side. Those don't match up, so I can only use side, side, side in this case. And there's your homework.